Hello, welcome to today's math lesson. Today we're going to learn about powers of 10. Our learning target is I can read and write powers of 10. So by the end of today's class, I want you to be able to read a power of 10 correctly and write one correctly. Are you ready to start? Let's go. Powers of 10 are a way of writing really large numbers in mathematics using just a few digits. And the way we do that is by using what's called exponents. And we write numbers in what's called exponential notation. That's a fancy word for a name of a number with an exponent. And so I have an example here so we can learn a little bit about exponents first before we dig into powers of 10. So any number written in exponential notation has two parts, right? And do you see them here? Right. So the first part of a number written exponential notation is the big number. This number is really big to make a point, but normally it's just written in regular size writing. And we call that the base. This is the base number. The exponent is the little tiny number written in the top right corner. Now, what does an exponent do? Well, an exponent is an operation. And what it does is it tells the mathematician, that's you, that you use whatever number's in the base and you multiply it by itself 4 times. So in this case, here, let me grab myself and get myself out of the way here. In this case, 2 to the 4th power is the same as 2 times 2 times 2 times 2. Do you see how we used 2, the base, 4 times? 1, 2, 3, 4. Right? So that's what an exponent does. It's a shortcut for repeated multiplication each and every time. So we find our answer by simply multiplying all these numbers together. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is, you got it, 16. So 2 to the 4th is equal to 16. All right. Want to try another one? Oh, look at this. This is our first power of 10. So a power of 10 is just a special name for a number written in exponential notation that has a base of 10. There's our base, the big number. It's 10, and that makes it a power of 10. Here's our exponent. So in this example, the exponent 5 tells us mathematicians to use the base 10 5 times in repeated multiplication. And so here you have it. We have 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5 tens. 5 tens. Let's do the math. Let's see. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is, let's see, 10,000. And 10,000 times 10 is, you got it, 100,000. Now there's a pattern here. Do you see any patterns or similarities between 10 to the 5th? Focus on the 5. 10 times 10 times 10 times 10 times 10 and 100,000. Look at the zeros. What do you notice? That's right. The exponent 5 tells us to use the base 10 5 times, which makes us use 5 zeros in the 5 tens, which also gives us 5 zeros in our product. So we can say the exponent 5 tells us how many zeros are in the factors that we're multiplying, and the exponent 5 tells us how many zeros are in the product of this exponential notation. Interesting, huh? Let's try another one. I want you to do this one. All right. Try it out. And I'll meet you on the other. What I want you to do is to write this number, 10 to the third power, both in expanded form like this. And I want you to find the product. I want you to find what is the value of 10 to the third power. Write them both down. I'll meet you on the other side of this problem. Go. Okay. Do you think you got it? Let's find out. The base tells us to use 10 3 times. I'm sorry, the exponent. Oh, I'm getting tired. The exponent tells us to use the base 3 times. So let's do that. Let's go ahead and start drawing. I don't have to draw. I forgot. I did something cool. We're going to just go ahead and get rid of that right there. Let's go ahead and get rid of it. Boom. Let's see. So we're going to take a 10. That's 110 times 10. Kind of cool, huh? I like playing around with this stuff. Oh, no, I didn't realize what was going to happen. Well, that didn't work. Hold on. I'm going to go ahead and delete that. All right. How about this? Delete. I know I'm going to grab everything, and I'm going to delete everything. Okay, now I'm just going to write. Okay, let's see. What did I mess up? Okay, so there was a big 10 there. 10 to the third power is equal to, let me get myself out of here. 10 times 10 times 10. 3 tens. So the exponent 3, 1, 2, 3 tens. So if we multiply that out, 10 times 10 times 10 equals, let's see, that's 100. 100 times 10 is 1,000. So that equals 1,000. And look at that. The pattern holds the same. The exponent 3 tells us to use 3 tens, giving us 3 zeros, which is also how many zeros are in our product when we get done figuring out the answer. So the exponent 3 can actually give us a shortcut to how many zeros are in our answer. All right. You ready for the next thing? Try this one. I'll meet you back on the other side of this problem. Again, write the number in this expanded form and write the actual product. Are you ready? Go ahead. All right, let's see how you did. I'm going to slide myself out of here. I'm going to go ahead and delete everything because I realize that that's not going to work. So I'll grab it all and I will delete it all. Let me move myself back and let's just use a pen. Old-fashioned style, right? As if we could be old-fashioned on a screen learning digitally and through the internet. All right, so the exponent 6, that tells us to use the base 10 6 times. 6 times. So let's save some space. We got 10 times 10, that's 2, times 10, that's 3, times 10 is 4, times 10 is 5, times 10. Wow, 6 tens. 1, 2, 3, 4, 5, 6 tens. So, well, we could do all the multiplication, but let's use that shortcut. We've been learning that this exponent actually tells us how many tens to use, and that number of zeros that's in all those tens, that exponent number, is going to be equal to the number of zeros in the answer. So all the ones, 1 times 1 times 1, those are all just 1. So let's start by writing the 1 with, let's see, 1, 2, 3, 4, 5, 6 zeros. Let's see, 6 zeros. And then we can put our comma in, 1, 2, 3, comma, 1, 2, 3, comma. So our answer is 1,000,000. 10 to the 6th power is equal to 1,000,000. And we could do the math to find out, to check to see if we're right. Let's see. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is 1,000,000. We're correct. Look at that. And look, the 6 zeros. There's a shortcut there because of all the zeros and the tens. So let's focus on that pattern for just a little longer before we get started with our practice work today, okay? We're going to fill out this chart, this table, together. All right, so standard notation. That's just a regular name for a number. So if we write the number, I'm going to use red now to make it show up. If we use the number 10, that's the regular name for the number. As a product of 10, well, you don't have to multiply 10 by anything to get 10, so it's just 10. And then in exponential notation, let's see, we have 110. We didn't multiply it by anything, so we just write 10 to the first power in exponential notation. Now, let's see what we do with the next number. So in standard notation, the number 100 is, you got it, 10 times 10. And there's two 10s there. So that's the base. The exponent we need is a 2 to tell us to use the base twice. So in exponential notation is 10 to the second power. And then we have, let's see, the next number is 1,000 in standard notation. That's like the regular name for it. And to get to 1,000, let's see, that'd be 100 times 10. So that's one more 10. 10 times 10 times 10. Yeah, and that's 1, 2, 3 zeros. 3 10s that we have to use as a base over and over. So 10 to the third power. Do you see a pattern? I want to stop the video right here. I want you to fill out the next row. And I'll meet you back on the other side to see if we did it correctly. Good luck. All right, we're back. Let's check it out. The next number is 10,000. And did you get that part? Now it's sort of the most important part. Yeah. 10,000 is 1,000 times 10. So that's, let's see, 10 times 10 times 10 is 1,000 times 10 is 10,000. That's 4 10s. So we have to use the base 4 times the exponent of 4, 10 to the fourth power. Let's pause again. Do the next row. I'll give you a hint this time. The next number is 100,000. Can you fill out the last few boxes in that row? Good luck. We'll talk about it in a second. Okay, let's figure it out. Let's see, 100,000 was 10,000 times 10. So 10,000 is 10 times 10 times 10 times 10. Okay, so that's the 100,000 from the row above. Now we need, I'm sorry, the 10,000 from the row above. So now we need to figure out what 100,000 is. So I think that's one more 10. And yep, look at that. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 5 10s, which means we're going to write this number in exponential notation as 10 to the fifth power. All right, last one. See if you can figure out the last row. Go ahead and fill out all 3 boxes, and I'll see you back on the other side of this problem. Okay, welcome back. Here we go. Let's see here. The number is going to be 1 million. Did you get that part? That's 1 with 6 zeros behind it. And the way we write that as a product of tens, sort of like a number sentence that is all tens, is 6 tens. 1, 2, 3, 4, 5. Oh, I got to go into the next box. 6. And in exponential notation, we're using 10 as the base, and we're multiplying it by itself 6 times. So we call that 10 to the power 6. That's equal to 1 million. All right. Now we're going to do a lot of work with a table like this and problems very similar to this so that we can write powers of 10, whether we write them in standard notation, whether we write them as products of 10 or in exponential notation. You're going to see all sorts of numbers written in all sorts of ways, and you're going to have to write them in the other ways. Okay, so those directions will be in the slide deck. That will be your practice work for today. All right, good luck, and let me know if you have any questions.